Hi guys, so today I'm going to be talking about how we convert from mass of our given to moles of our find, okay? So I have my periodic table ready to go, I have my stoich map, and then I have our notes for us, okay? So the first thing I want us to focus on is how we set up these formulas, okay? So we are always going to set them up like this. So if you want, this would be a great time for you to pause and kind of write this down somewhere. So we're always going to start with the mass of what we're given. And if it helps us, we can put this over a 1. That's just a placeholder, okay? Then we're going to use our conversion factor of molar mass to 1 mole. So we're always going to have the molar mass of what we're given underneath 1 mole of what we're given. So that helps us, or that allows us to convert from grams to moles. After that step, that's where our mole ratio comes into play. Okay, so we're going to have our moles of what we're given underneath the moles of what we're trying to find. And remember, the mole ratio, the numbers for this come from our balanced chemical equation. So when we put these all together, we're going to be able to find the moles of whatever substance we're trying to find. Okay, so the example I've written for us in purple says, if I start with 8.71 grams of sodium, how many moles of sodium chloride can I make? Hint, chlorine is a reactant, okay? So first things first, let me get this set up for us. Remember, we always need to start with a balanced equation, okay? So I know that I'm starting with sodium. So sodium's formula or symbol, and I'm going to use my periodic table for this, is Na. So I'm going to start with Na. And my hint says chlorine is also a reactant. So it's going to be Na plus Cl2. It's Cl2 because chlorine is one of our diatomic elements, meaning whenever it's by itself, it always gets a baby 2. And I'm going to make sodium chloride. So we're going to put these two elements together and we're going to get NaCl. Check the charges. Sodium has a +1, chlorine has a -1, so I don't need to switcheroo anything. Now that I have the skeleton, I'm sorry, my cat just jumped up on the table. Now that I have the skeleton equation, I'm going to balance it. So I have 2 chlorines on my reactant side. So I need 2 on my product side. So I'm going to put a 2 in front of my NaCl. That changes how many NAs I have. So I have 2 sodiums on my product side, and I only have 1 on my reactant side. Frank? He just wanted to say hi. So, like I said, I have 2 sodiums on my product side, but only 1 on my reactant side. So I'm going to add a coefficient of 2 here. Okay, so we have our balanced equation. So now it's time to actually do the conversion. So remember, we're going to use this formula setup here. So we're going to start with what's given to us and what we are trying to find. So we were given 8.71 grams of Na. And we're trying to find moles of NaCl. Okay? So the mass of the given, so 8.71 grams Na over placeholder 1. And then we're going to put the molar mass of what was given to us. So this is going to be grams of Na, and the molar mass of sodium chloride is going to be 22.99. So let me get my calculator. 22.99 plus 35.45. Okay? And that gives us a 58.44 grams. And that is for every 1 mole of our given, which is our Na, and a dot and a line. So now I'm at my mole ratio. So I'm going to have mole of given, which is my Na, underneath my mole of find, so mole NaCl, and then my equal sign. So for my mole ratio, I need to look at my balanced equation. So to determine what number is going to go with my moles of NaCl, I need to look at the coefficient. So I'm going to put a 2 here because that's the coefficient in front of NaCl. Looking at Na also has a coefficient of 2, so I'm going to put a 2 here. Okay? So I have set it up following the setup I outlined above. So to do this math, I'm going to take 8.71 times 2, and that gets me 17.42, and I'm going to divide that by 58.44. So that gives me a final answer of 0.30 moles NaCl. And, whenever we go from grams to moles, we expect the number to be smaller. So we're on the right track. Another great way to double check your work is to check your units. So if I have a unit on the top and that same unit on the bottom, I know that they're going to cancel each other out. So I have grams of sodium on the top and grams of sodium on the bottom. They cancel out. Rules of math. Mole Na, mole Na. So those are going to cancel out. And I know that I'm going to be left with moles of NaCl in my final answer. So that's a great way to check that you're on the right path. So again, that was just one example of going from mass to moles. Remember, this setup will help you when you're trying to do these calculations. And hopefully we get this down good. All right. So